In this video, let us solve problems on variation of parameters. So here we have a question: solve d square y by dx square minus y equal to 2 divided by 1 plus e raised to x by the method of variation of parameters. So it was given in VTU exams June 2005. So now, whatever the given problem is there, it has derivative d by dx. So here put d by dx equal to capital D. If you substitute d by dx equal to capital D, so here we have d square by dx square. So capital D square y minus y equal to 2 divided by 1 plus e raised to x. So now y is common throughout. So if you take y common, this implies d square minus 1 into y equal to 2 divided by 1 plus e raised to x. So now it has y as well as x, so it is called non-homogeneous equation. So in case of non-homogeneous equation, so general solution y equal to CF plus PI. So let us find out CF and PI separately. So first let us find out CF. For that refer LHS. LHS we have d square minus 1. So replace d by m, we get auxiliary equation. So auxiliary equation or intermediate equation is m square minus 1 equal to 0. So m square equal to 1, m equal to plus or minus 1, plus 1 minus 1. So m values are 1 and minus 1. So once you get the roots, check whether they are equal or not equal. Now 1 and minus 1 are not equal. So CF we write it as C1 e raised to 1x, C2 e raised to minus 1x. So if you compare with C1 y1 plus C2 y2, so here multiple of C1 is y1, so it is y1 is e raised to x plus y2 C2 y2 y2 is e raised to minus x. So once you get y1 y2, find out w, Wronskian of y1 and y2. Then it is defined as determinant of y1 y2 y1 dash y2 dash. Now substitute y1 and y2, e raised to x, y1 y2 e raised to minus x, y1 dash derivative of e raised to x, it is e raised to x, y2 dash derivative of e raised to minus x minus e raised to minus x. So this is what we get. So determinant, so plus minus, so multiply both e raised to x into minus e raised to minus x. So when you multiply, it will be e raised to minus sign e raised to x e raised to minus x minus e raised to minus x into e raised to x. So now here e raised to x e raised to minus x, e power 0 which is 1. So minus 1 minus 1 which will be minus 2. So we get w value is minus 2. So now let us move further to find pi. So in case of variation of parameters, pi equal to, it has two terms, y1x by w and y2x by w. So y1 term is multiplied by y2 into integration of this, then y2 term minus y1 into integration of this. So y1 we know e raised to x, y2 e raised to minus x, w which is minus 2, then capital X means RHS x term. So here capital X is 2 divided by 1 plus e raised to x. So substitute these terms, so then we get y2. So y2 is e raised to minus x, integration of y1 e raised to x into capital X is 2 divided by 1 plus e raised to x whole divided by w which is minus 2. So minus y1, so y1 is e raised to x, integration of y2 e raised to minus x, capital X 2 by 1 plus e raised to x whole divided by w minus 2. So if you look at this integral, here 2 and 2 get cancels, minus sign take outside. So it can be written as minus e raised to minus x integration of e raised to x divided by 1 plus e raised to x. Minus, here also 2 get cancels, minus of minus plus sign, e raised to x integration of e raised to minus x divided by this. So e raised to minus x can be written as 1 by e raised to x into bracket 1 plus e raised to x. So this is what you will get. Now here look at the terms. Now anyway we need to integrate both the terms. So let us concentrate on first term. So minus e raised to minus x. So denominator is 1 plus e raised to x, numerator is e raised to x. So derivative of denominator is at numerator. So we know the result, integration of f dash of x divided by f of x is equal to log of f of x, log of f of x. So if you apply this, so f of x is this, f dash is this, so it is integration of this is log of 1 plus e raised to x plus e raised to x into integration of this 1 by some x into 1 plus x. So here what we can do is, now at this position we cannot integrate, so you need to rearrange the terms. For that we have a result 1 by x into bracket x plus 1 can be written as 1 by x minus 1 by x plus 1. So when you cross multiply, it will be x plus 1 minus x getting cancels, 1 by x into x plus 1 you will get. So integration of it can be written as 1 by e raised to x minus 1 by 1 plus e raised to x. Now so this part as it is, first term as it is, plus e raised to x into bracket integration of, so here from this 1 by e raised to x is e raised to minus x minus, so in second term integration of first term is over, it is integration of e raised to minus x integration of 1 by 1 plus e raised to x. So now here first term as it is plus e raised to x integration of e raised to minus x, which can be written as e raised to minus x divided by minus 1 minus into bracket, we will let us use the brackets. So now integration of 1 by 1 plus e raised to x. So now at this position again we cannot integrate, so take common. So here from denominator e raised to x common, if you take, it can be written as 1 by e raised to x into bracket, if you take outside, so you will get e raised to minus x plus 1. So now this term as it is plus e raised to x as it is into bracket minus e raised to minus x minus, so 1 by e raised to x it is, so it can be written as e raised to minus x divided by e raised to minus x plus 1. Now so this term as it is plus e raised to x into bracket minus e raised to minus x. So now look at the denominator, so e raised to minus x plus 1, its derivative is minus sign e raised to minus x. So we can apply this result. So integration of f dash by f is log of f of x. In the same way, so here we can write it as log of e raised to minus x plus 1. So finally we can write pi as first term as it is minus e raised to minus x log of 1 plus e raised to x plus e raised to x into e raised to minus x, multiply this one, e raised to 0 minus 1, so now multiply plus e raised to x into bracket log of e raised to minus x plus 1. So now this is what we get, pi. So final solution of the given problem is y equal to, from equation 1, from 1 y equal to CF plus PI, CF plus PI. So here CF is this C1 e raised to x plus C2 e raised to minus x minus 1 minus e raised to minus x log of 1 plus e raised to x plus e raised to x log of e raised to minus x plus 1. So this is the final solution of given problem. Now let us solve this problem. Solve y double dash minus 2y dash plus y equal to e raised to x log x by method of variation of parameters. So in this problem it has been given in VTU exams in the year 2014. So here y double dash means d square y minus 2y dash means dy plus y equal to e raised to x log x. So here throughout y is common, so if you take y common it can be written as d square minus 2d plus 1 into y equal to e raised to x log x. So here it has y term as well as x term, so it is non-homogeneous equation, non-homogeneous linear differential equation. So in case of non-homogeneous, we know general solution y equal to CF plus PI. Take this as equation number 1. Now we need to find CF and PI separately. Let us start with CF, for which refer LHS, which is d square minus 2d plus 1. By referring this, write auxiliary equation, that is replace d by m square minus 2m plus 1 equal to 0. Now factorize and find the m values. 1 can be factorized as minus 1 into minus 1. So product 1 add minus 2. So it can be written as m minus 1 into m minus 1 equal to 0. So product 0 means m minus 1 0, m minus 1 0. So m value 1, m equal to 1. So total m values are 1 comma 1. So once you get roots, check whether equal or not equal. Now it is equal, 1 is equal to 1. So in case of equal roots, we know how to write CF. CF is C1 plus C2x e raised to 1x, or e raised to x if you multiply, it can be written as C1 e raised to x plus C2 x e raised to x. So once you, this is the half of the solution. Here multiple of C1 is e raised to x, which is called y1, and multiple of C2, that is x e raised to x, it is y2. So once you get y1 and y2, then you go for W, Wronskian of y1 and y2, which is determinant of y1 y2 y1 dash y2 dash. So y1 is e raised to x, y2 x e raised to x. Second row y1 dash, derivative of e raised to x, that is also e raised to x. Then y2 dash, so derivative of x e raised to x. So it is a product of two terms, so we need to apply u into v rule. U into v dash, x into e raised to x plus u dash into v, x derivative 1 into e raised to x. So this is y2 dash. So once you get this, solve the determinant, 2 cross 2 determinant, multiply principal diagonal elements. So x into e raised to x, e raised to x, e raised to 2x, e raised to x, e raised to x, e raised to 2x, minus, then multiply secondary diagonal elements, e raised to x into x e raised to x. So it is x e raised to 2x. So x e raised to 2x, x e raised to 2x get cancels here. So we get e raised to 2x, which is W. So we got W. So now you go for PI. So this is half of the solution. then let us go for pi. So in case of method of variation of parameters, pi has two terms. One is y1 x by w, another one is y2 x by w. So y1 x by w is multiplied by y2 into this. Then this second term is multiplied by minus y1 into integration of that term. So now you need to solve these two integrals. So y1, y2, that we know, y1 is e raised to x, y2 x e raised to x. Then w also we know, that is e raised to 2x. So for this problem, capital X means x term in the given problem. So here x term is e raised to x log x. So capital X is e raised to x log x. So now we know all the terms, substitute and simplify. So first let us start with y2, substitution, y2 x e raised to x, integration of y1 e raised to x, capital X is e raised to x log x divided by w is e raised to 2x, minus y1 e raised to x, integration of y2 x e raised to x, then capital X e raised to x log x whole divided by w is e raised to 2x. Now here in this integral, numerator e raised to x, it is e raised to 2x divided by e raised to 2x. So this term get cancels. Here also e raised to 2x get cancels with e raised to x. So now we get here x e raised to x integration of log x minus e raised to x integration of x log x. So like this we got integrals. So now we need to evaluate these integrals. So here log x, we don't know the result for log x, and also we need to simplify this by product rule. So we know the product rule. Product rule is integration of u into v is u into integration of v minus integration of v differentiation of u. So like this we have the product rule. To apply this, you need to choose one term as u, another term as v, based on I late principle. Means first inverse, then log, then algebra, trigonometry, exponential. Logarithmic term first, then algebra. So log x, take it as first function, into 1, take this as 1, this as second function, u into v. Similarly log x u, this one as v. So apply the product rule. Here x e raised to x, so u integration of u is u into, means log x into integration of v, 1, integration of 1 is x, minus integration of v, integration of v is x, differentiation of u, log x differentiation 1 by x. This is first term, minus e raised to x into here log x u into v, u integration of v, x integration x square by 2 minus integration of v, that is x square by 2, then du, differentiation of log x 1 by x. Now simplify x e raised to x into bracket x log x minus x get cancels, integration of 1 minus e raised to x into bracket x square log x by 2 minus, here x get cancels, 1 by 2 integration of x. We get this. So let us simplify further. X e raised to x into bracket x log x minus integration of 1, that is x, minus e raised to x. So here if you take 2 common outside, then x square log x minus integration of x, that is x square by 2. So this is what we got pi, but still what you can do is take the common terms. So in first term x common, take outside, so x square e raised to x into bracket log x minus 1 minus, here x square common, x square e raised to x by 2 into bracket log x minus 1 by 2. So now throughout we have x square e raised to x. So if you take x square e raised to x common, we get log x minus 1, then minus 1 by 2 multiply minus log x by 2, then minus of minus plus 1 by 4. So if you simplify, it can be written as x square e raised to x into bracket log x minus log x by 2, 1 minus half log x by 2, then minus 1 plus 1 by 4, so minus 3 by 4. So like this we get the pi. So this is the pi, whatever you got. Then the final solution is final answer y from 1 y equal to CF plus pi. So let us solve another problem. So here the given equation is y double dash minus 2y dash plus 2y equal to 0 e raised to x tan x. So here y double dash means d square y minus 2 y dash means dy plus 2y equal to e raised to x tan x. So here throughout y is common. If you take y common, it can be rewritten as d square minus 2d plus 2 into y equal to e raised to x tan x. Here it has y as well as x term, so it is called non-homogeneous equation, and we know in case of non-homogeneous equation, general solution y equal to CF plus pi. So let us find out separately CF and pi. So first let us find out CF. So in this problem, what is CF? So here CF, to find CF, write the auxiliary equation. So auxiliary equation m square minus 2m plus 2 equal to 0. It is a quadratic equation, so you need to think of factorization, but when you take 2 into 1 is 2, but addition is 3, which is not there here, so factorization is not possible. Then you need to go for Sridhar's formula. So whenever we have ax square plus bx plus c equal to 0, a quadratic equation, then the root x equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So this is the root. So in the same way you need to solve this. So here identify a1, b minus 2, c 2. So here m equal to minus b, b is minus 2, minus b minus of minus 2 plus 2 plus or minus square root of b square. So b square is 4 minus 4ac, 4 into 1 into 2, 8 divided by 2 into 1, 2. So 2 plus or minus square root of 4 minus 8 is minus 4 divided by 2. So 2 plus or minus square root of minus 4. Square root of minus 4 is square root of minus 1 is I, and square root of 4 is 2. So that is 2i divided by 2. So it can be written as 2 by 2, which is 1, plus or minus 2i by 2 is I. So 1 plus or minus I. It is of the form alpha plus or minus I beta, where alpha is 1, beta is also 1. So for this case, CF is e raised to alpha x, e raised to 1x into bracket c1 cos x, c1 cos beta x, beta is 1x, c1 cos x plus c2 sin beta x, beta is 1 into sin x. So multiply e raised to x, you will get e inside. So c1 e raised to x cos x plus c2 e raised to x sin x. So in this problem we can identify multiple of C1. So this is y1. So here y1 is e raised to x cos x, y2 multiple of C2 e raised to x sin x. So from this we got y1 and y2 from CF. So now let us go for PI. So before PI you must find out W, Wronskian of y1 and y2, which is defined as determinant of y1 y2, second row is y1 dash y2 dash. So in this case y1 is e raised to x cos x, y2 e raised to x sin x, y1 dash. So this is a product of two terms, u into v form. So apply the u product rule. U into v dash is u into v dash plus u dash into v. So u e raised to x into v dash cos x derivative minus sin x plus u dash e raised to x v cos x. In the same way u into v, here e raised to x cos x plus e raised to x sin x. So this is what we got the determinant terms. Now then you go for simplifying the determinant. Before simplifying, here first row is having common e raised to x, take outside e raised to x. Then second row is also having e raised to x, so take common. So e raised to x common. So the terms are cos x sin x. So here cos x minus sin x, here cos x plus sin x. So now e raised to 2x outside. So determinant, so solve this determinant, multiply principal diagonal elements, cos x into cos x, cos square x plus cos x sin x minus sin x into cos x minus sin square x. Now here cos x sin x minus sin x cos x cancels, e raised to 2x into cos square x minus of minus plus sin square x. So cos square plus sin square is 1, so we get e raised to 2x. We have y1 e raised to x cos x, y2 e raised to x sin x, w e raised to 2x, capital X e raised to x tan x. So once you get all these, then you go for finding PI. So PI is, it has two terms, y1 x by w, another term is y2 x by w. So y1 x by w multiply by y2 into integration of this term minus y1 into integration of y2 x by w. So substitute y2 e raised to x sin x integration y1 e raised to x cos x into capital X e raised to x tan x divided by w e raised to 2x minus y1 e raised to x cos x integration of y2 e raised to x sin x into capital X e raised to x tan x divided by w, that is e raised to 2x. So here numerator e raised to x, that is e raised to 2x, denominator e raised to x. So that term get cancels. Then here e raised to x sin x integration of cos x into tan x. Tan is sin by cos. So cos get cancels, you will get sin x minus e raised to x cos x into integration of sin into tan. Tan is sin by cos, so sin into sin, sin square, so sin square x by cos x. Now e raised to x sin x, integration of sin is minus cos x minus e raised to x into cos x, integration of sin square by cos. So we don't have any result. So what you can do is sin square can be written as 1 minus cos square x. divided by cos x, because sin square x plus cos square x is 1. So sin square x can be written as 1 minus cos square x. Now, so this first term is minus e raised to x sin x cos x, this one as it is, minus e raised to x cos x into integration of, so now divide separately. 1 by cos x is sec x minus cos square by cos, so cos get cancels, you will get cos x. So first term as it is, minus e raised to x cos x integration of sec x, that is log of sec x plus tan x, minus integration of cos x is sin x. So now let us simplify. So first term minus e raised to x sin x cos x minus e raised to x cos x into log of sec x plus tan x, so minus e raised to x cos x into plus minus sin x, so it will be plus e raised to x sin x cos x. So here plus e raised to x sin x cos x minus e raised to x sin x cos x get cancels, and pi will be minus e raised to x cos x log of sec x plus tan x. So this is what the pi is. So once you get pi, then final solution from 1, y equal to cf plus pi. Thanks for watching this video completely. Hope you have understood these problems. In case of any difficulty, comment below, I will reply. Please subscribe my channel and also share these videos with your friends. God bless you. Thank you.